Next topic in Unit 4 is working with functions. So a function is a relation where each input has one and only one output. So what that means is each x has exactly one y. To determine if a relation is a function from tables and ordered pairs, we always look at the x values. That's where we always start. If they're all different, then you automatically have a function. If any of them are the same, then you look at the outputs or the y values for just those x's. If the y values are also the same, then you have a function, but if the y values are different, then you do not have a function. So let's look at some examples. It says determine if the relations are functions. So again, we always start by looking at our x's. So I see a 1, a 3, a 2, and a negative 2. Since none of those x values are the same, it's automatically a function. None of my x is repeated. They're all different. Looking at number 2, again, we start with our x values, 1, 3, 2, 3. Well, that 3 repeated, so I look at the y values now. I see a 1 and a 6. So because the y values are different, 1 and 6, this is not a function. Looking at number 3 again, always start with our x values. I see 1, 3, 2, and 3. Again, those 3's repeated, which means I need to look at their y values. This y value is a 1, and that y value is a 1. So because the y values are also the same, this one is a function. So I just want to show you how I was taught in high school to think about functions, and if it helps you, that's great. I was taught to think of functions like a soda machine. So when we think about soda machines, we can have a Sprite button. There could be a Coca-Cola button, and Coke is pretty popular, so we have 2 Coca-Cola buttons. Now, when I push this Coke button, I expect to get a Coke, and when I push this Coke button, I expect to get a Coke. So, same soda, same output. But if I push this Coke button and a Sprite comes out, well, that's not what I wanted. So I have a broken machine now. So in that same idea, we can have repeating x values. We can have multiple Coke buttons or x's. But if their y values or their outputs are not the same, then it's a broken machine. It's not a function. Okay, so if that helps you, just a different way to think about it. So looking at number 4, now we're dealing with tables. Again, we look for repeating x values. I see 2 negative 3s, so I look at their y values. 4 and 5, different numbers, so it is not a function. And looking at number 5, do any of the x values repeat? No, which means it's automatically a function. If you have questions about tables or ordered pairs, please make sure you pause your video before moving on. Otherwise, to determine if a graph is a function, we use the vertical line test. So the vertical line test says that if you pass a vertical line over a graph, the line may only touch the graph at one point at a time to be a function. If the vertical line ever touches more than one point, the graph is not a function. So what that means is I should be able to draw a vertical line anywhere on my graph, and it should only hit the graph at one point. So I draw a vertical line, it hits there, 1 point, still 1 point, still 1 point. So anywhere I draw a vertical line, it only hits the function once. So it is a function. Looking at number 7, if I draw a vertical line here, well, it hits the graph there, and it hits the graph there. So now it's hit more than 1 point, which means this is automatically not a function. It does not pass the vertical line test. Now number 8 is a little tricky. If we think back about what open and closed circles mean, a closed circle means the number is included, and an open circle means the number is not included. So looking at this, at -3, if I draw a vertical line, it hits here and it hits there. But there was an open circle. This was open and this was closed, which means that it really only hits at one point. It only hits at this point right here where it's closed. So with that same idea, at 2, again, it looks like it hits more than one point, but because this one is closed and that one is open, it doesn't hit the graph more than once, so it is a function. If you had 2 closed circles, then it would not be a function, because then it's hitting 2 points on the graph. So domain and range, the domain of a relation or function is the set of all inputs, or x values, which we call the independent variable. The range of a relation is the set of all outputs, or y values, which we call the dependent variable. So to remember this, we have 2 acronyms, DIX and ROY. Domain, input, x values, and then range, output, y values. So at the end of our notes, we'll add that to our formula sheet. All right, inverse. The inverse of a relation or function is the inverse of the ordered pairs, and we'll talk about what that means on the next page. So in our examples 9 and 10, it says state the domain, range, and inverse. So we'll start with the domain. Remember, domain is our x values. So we are talking about 1, 3, 2, and -2. But since it's a set of numbers, we write them in ascending order, least to greatest. So I have -2, 1, 2, and 3. My range, we look at our y values. So I have 3, 3, 3, 3. Well, what the heck? They're all the same. So what do I do when I have repeating numbers? Again, we put them in braces, and I only write it once. I do not need to write it more than once if it's the same number. All right, and then the last thing it asks for is inverse. So with inverse, all you're doing is flipping the x and y value. So we, again, put them in braces. So looking at my first ordered pair, it's 1, 3. So rather than writing 1, 3, we flip them and write 3, 1. Now the next one, 3, 3, same number, so we just write it like that. My next ordered pair, 3, 2, and then 3, -2. All right, so looking at number 10, again, we always put them in braces. They're a set of numbers, and we always put them in order from least to greatest. So I'm only looking at my inputs. Remember, DIX, domain, input, x values. Least to greatest, -6, -3, 0, and 3. Close out with braces. And then we look at my outputs, ROY, range, output, y values. Again, put them in braces, least to greatest, -6, -5, -4, and -3. And lastly, we have inverse. So remember, we're flipping the order of the ordered pairs. So this is our ordered pair, 3, -3. But rather than writing 3, -3, we're going to write -3, 3, -4, 0, -5, -3, and then -6, -6. Close it out with braces. If you have questions about how to write those, domain, range, or inverse, again, as always, please pause your video before moving on. Otherwise, we're going to talk about domain and range in graphs, and this is probably the hardest part of this topic. So when we're talking about notations, remember we have set and interval notation. So the directions say state the domain and range of each graph. So when we're talking about domain, we're talking about our x's. So we're talking about smallest x to largest x. So if I kind of pretend to drop this invisible little line here, my smallest x is 1, and my largest x is 5. Thinking about range, we're thinking about our y value, so I have to think about my y-axis. So I'm going to draw a horizontal line. I see a 2, and my largest y value is 4. Okay? And that's going to help us with writing set and interval notation. So for set notation, we'll start with domain. Remember, set notation is the one with braces. So we start the set of all, which variable represents domain, x, such that, now this example is a little tricky because we have two numbers that x could fall in between. It's between 1 and 5. So our smallest x is 1. Now I have a closed circle here. So less than or equal to, and we draw our x, which is, now I have an open circle, so less than 5. And we close our braces. So again, if we look at that inequality that we just wrote, it says x can be anywhere from 1 up to less than 5. So it can be 4.9999999 repeating, but it can't be 5. And then with our range, the set of all, what variable are we talking about with range? Y's, such that, and again we have a two-part inequality here. So it starts at 2, again, closed circle, less than or equal to y. And then with our open circle, our largest y is 4, but it can't be 4, so it's just y is less than 4. So again, we have a two-part inequality there. Y can be greater than or equal to 2, but it has to be less than 4. All right, so that's set notation. Now in interval notation, which is probably the easier way to write these problems, we are talking about parentheses and brackets. So my first number is closed. I have a closed circle up here. So I have a bracket, and my smallest x is 1, my biggest x is 5, and because that 5 is an open circle, we put a parentheses around there. And then with range, again, my smallest number is 2, and it can be included, so it's a bracket. And then 4 is my greatest number, but we can't include 4, so a parentheses goes around there. If you have questions about this problem, please make sure you ask questions before moving on. Otherwise, we are going to go talk about number 12. So again, our smallest x this time is 1. If these arrows keep going, what's happening to my x values is those arrows keep going to the right. They're heading towards infinity. Now with our y's, we have to think about it a little differently. As this keeps going on forever, what's happening to our y-axis here? It's heading towards what? It's going towards negative infinity. Our largest y, if this keeps going up, our y's keep going up, so they're slowly heading towards infinity. And you can kind of think about it like smushing the graph. And if you want further explanation on that, I'd be happy to walk over and help you explain what that means. Okay? All right, so for set notation, again, we'll start with domain. The set of all x's such that, all right, so we're starting with 1, and then we're going to infinity. So all my x's are what? X is greater than or equal to 1. Now, why is it greater than or equal to? Because there's no specific open circle that we can see, it's implied that it's closed and we're including the number. So 1 is included. All right, and then for range, the set of all y's, such that, now looking at our y values, it's negative infinity to infinity. So it's all the numbers, right? Remember how to write that in set notation? Y, and then our capital E, y includes all real numbers. Again, I think interval notation is easier to use, but it's totally up to you, whichever is your preference. So for interval notation, we start at 1, and we go to infinity. Always put parentheses around infinity signs. And then for our range, negative infinity to positive infinity. With parentheses on both sides, because we're not including infinity. Before we move on to your UDOs, we're going to go add to our formula sheet. So at this time, if you could please pull that out. DIX and ROY, which stands for domain input X value, and then range output Y value. And remember, at the end of this unit, we have a formula quiz, so make sure that you're getting these formulas and acronyms embedded into your brain so you can remember them and do outstanding on your formula quiz. All right, if you would go back to your UDO problems just so I can explain the directions really quickly. So the directions say determine if the relation or graph is a function. So you're doing that for 1 through 7. Tell me if it's a function or not a function. For 1 through 5, you're telling me the domain, range, and inverse. For 6 and 7, you're just telling me domain and range, and you can write it in set or interval notation. It does not have to be both. You can pick whichever one you'd prefer. So if you don't have any questions, you can go ahead and get started on those UDOs.